We have been working with ratios, with unit rates, with proportions, and we're going to work today with ratio tables. And ratio tables are basically just another way that you can write equal ratios and you can display ratios that are equivalent. So let's look at an example. If we look at the situation that says Jarrett can run 4 laps around the track in 10 minutes, we could show that as a chart, a ratio table that looks like the one that I've written, the ratio of minutes to laps. And when I look at that, I can see that it takes him 10 minutes to run 4 laps, just like it says in my problem. He can run 4 laps in 10 minutes. And I could have put the laps on top and the minutes on the bottom. It doesn't particularly matter necessarily. But as I've told you all, we typically try to do the bigger number on top if we can when we're writing ratios. That's why I did it this way. But you could do it the other way as well. And so when we go to work with this ratio table, as long as I know at least one ratio in the table, I can fill out any missing numbers that I want to in the table. And because basically what this is saying is it's saying I have a ratio of 10 minutes for 4 laps. And when I look at this first box right here and I'm looking for this answer, what that's saying is then if he ran for 20 minutes, how many laps could he run? Now think about how we can solve that. We can totally solve that by cross multiplying and then dividing. 4 times 20 is 80, and 80 divided by 10 is 8. So our answer here is going to be 8. He could run 8 laps in 10 minutes. But you may be realizing that when you're looking at this, you actually can also use a scale factor. What I mean by that is you could look at this and look for a relationship in your ratio table. So in other words, you could be looking and saying, well, looking at the numbers of minutes at the top, is there a relationship between any of the numbers? And definitely, from 10 to 20, there's definitely a mathematical relationship. 10 is a factor of 20, so I can say 10 times 2 is 20. So the idea of a scale factor is then I would have to do the same thing to the 4 to get my missing number. Well, 4 times 2 does give me that same answer of 8. So if he ran for 20 minutes, he would be able to run 8 laps. So now when I look at the 25, I don't really see an easy relationship to go from 10 to 25, so I'm going to skip that one for now. Although notice I could set it up by doing a ratio of 10 to 4 is equal to 25 to what? And I could solve it that way. I'm going to come back to that, but for now, let's move on to something different. So I can also look and say, oh, wait a minute, there's a ratio for how I can go from 4 to 2. There's a relationship, rather, for how I can do that. I can do 4 divided by 2 to get 2. So if I can do 4 divided by 2 to get 2, then guess what? I can do 10 divided by 2 to get 5. So my missing number is 5. Now, one thing I want to point out to you is that dividing by 2 is the same thing as multiplying by 1/2. And we think about scale factors. Technically, scale factors were multiplying. So I could have thought about that as multiplying by 1/2 also. All right. And now when I look at this, I should be able to see a relationship between the 5 and the 25 that's going to make this easier to solve. I can do 5 times 5 to get 25. So then that would allow me to do 2 times 5 and get 10. And so now I have found all my missing numbers in my ratio table. Now I do want to go back and look for just a quick minute at what I wrote up here about, up at the top, about how I could have used the ratio of 10 to 4 to get the ratio of 25 to what? If I use cross multiplying and then dividing, 4 times 25 is 100, divided by 10 is 10, just like what I got right here. So keep in mind that you can use either method to solve this. If scale factors are not working well for you, then using the cross multiplying and then dividing is going to be a way you can definitely do that. All right, now let's say that I wanted to figure out then the number of minutes per lap. I can take any of my ratios up here. It does not particularly matter which one, but I'm going to use the 10 and the 4 because that's the first one I started with. But again, it would not matter if I wanted to, I would get the same answer either way. If I wanted to find the number of minutes per lap, I could say, well, 10 minutes in 4 laps is equal to how many minutes for 1 lap? And so when I cross multiply and then divide, 1 times 10 is 10, divided by 4 is going to give me my missing number. And my missing number then is 2.5 or 2 5/10. So it takes 2.5 or 2 5/10 minutes to complete 1 lap, 2.5 minutes per lap. All right, let's look at another ratio table. On this ratio table, the situation is my mother used 12 lemons to make 20 cups of lemonade. So when we look at this chart looks a little different, but it's really the same exact thing. I could have made this chart going across like this. Either way, it means the same thing. So if you don't like the chart written vertically, the ratio table written vertically, then it's totally okay to rewrite it going horizontally. Just make sure that you keep all the numbers for lemons in the lemon column and in the lemon row, and all the numbers for lemonade in the lemonade row. So my numbers in the lemons row, I should do that in blue so we can see that what we're matching here. So the numbers in the lemons row match the numbers in the lemons column. The numbers in the lemonade row match the numbers in the lemonade column. So if I wanted to, I could rewrite it whichever way makes the most sense to me. So even though that takes a little bit more work, if it makes more sense to you, then it's a fantastic strategy to use. All right, so let's look at filling out this ratio table. I'm going to just use the vertical one because that's the one that was initially given to me, and I want you to see what that one would look like. So I want to find relationships between numbers that are in the same column. So for example, I might say, oh, wait a minute, I see that I can do 3 times 10 to get 30. And that's great. However, I don't have a number over here to multiply by 10 to get that other missing number. So I have to start somewhere else. I might start by saying, oh, wait a minute, 12 divided by 4 is 3. Remember, dividing by 4 is the same thing as multiplying by 1/4. And so then 20, I would have to do 20 divided by 4 also, or multiply by 1/4. So 20 divided by 4 or multiplied by 1/4 is 5. So the missing number for this spot is 5. Now, that would allow me to finish out this one that I wrote here in green, because I could say the relationship to go from 3 to 10 is times 10, or 3 to 30 rather, is times 10. So I could do 5 times 10, and that's going to give me 50. So a ratio of 30 to 50 is equal to a ratio of 3 to 5, which is equal to a ratio of 12 to 20. All of those ratios are equivalent ratios. All right, as I continue working on this, I might now look and say, well, do I see some other numbers that have a relationship? And yes, I do. I can see 5 times 2, which equals 10. So I can use that scale factor here and say 3 times 2 is equal to 6. So my missing number here is 6. Now notice, if I had done this in a different order, do you see I could have also said 6 times 5 is 30, and 10 times 5 is 50. So everything I should be able to relate any ratio to any other ratio using a scale factor. The scale factors might not always be whole numbers, so sometimes they're not easy to find, but every ratio that is equivalent does have a scale factor that shows how they're equivalent. All right, so I have one missing number left, and I could relate that 9 to the 3. So if I wanted to do that, I could look and say 3 times 3 is 9. So I can do 5 times 3 and get 15. I have now found all of my missing numbers in my ratio table. And so now what I have found is that the ratio of lemons to lemonade and I could write it in all these different ways, is equal to a ratio of 12 to 20, or it's equal to a ratio of 3 to 5, or it's equal to a ratio of 9 to 15, or it's equal to a ratio of 6 to 10, or it's equal to a ratio of 30 to 50. All of those ratios are equal to one another. And when you do if you do your ratio table going across, that also makes it really easy to see that bridge map idea. All right, I want you to take a look at another one. Take a look at this one. This situation is about mixing pancakes. You have to mix 3 cups of pancake mix with 4 cups of water to make pancakes. So take a moment, work on this one, and see if you can figure out your missing numbers. Pause while you do it, and when you're done, hit play and see if you were correct. All right, if you have done your work correctly, these are the answers that you have. That last row, you might have written your own ratio in because you could find one from that. And so to look at the relationships that gave me this answer, I will tell you that what I did is I said, well, 3 times 2 is 6, and 4 times 2 is 8. And then I looked and I said, well, I can do 3 times 4 to get 12, and 4 times 4 gives me 16. I can do 8 times 5 to get 40. So 6, I can do rather 8, I can do 6 times 5 rather to get 30, which allows me to do 8 times 5 to get 40. And then when I look at the 21 and the 28, where I got those from is I said, well, I can do 4 times 7, and so 3 times 7 is 21. That's where I got those answers from. Now, I could use any of these then to write another equivalent ratio if I wanted to do that. For example, I could say, well, 3 times 6 is 18, and so 4 times 6 is 24. A ratio of 18 to 24 would be equal to all of those. So the key idea with this is you can totally use scale factors if you want. You could also set these up using bridge maps and set up a proportion, and then use cross multiplying and dividing to find your missing numbers in your ratio table.